Hello and welcome back on Root Access Berlin. We are recording again from the new studio at the factory. And today I have with me Mustafa Sezgin from SoundCloud. Hello Mustafa.
Hi.
Can you introduce yourself?
Sure. So I'm the Director of Mobile Engineering at SoundCloud, and I lead up basically the native mobile applications and the development of those at SoundCloud at the moment.
And so you wanted to tell us about a design pattern that you have recently started using at SoundCloud.
Yeah. So one of the common problems that we have on native mobile applications is having to obviously have a responsive user interface. And to do that, you generally need to jump off the main UI thread to retrieve some work where the information comes from some I/O source, whether that's from the network or from the data. There are a lot of components built into some of these SDKs that help with that, but one of the recent frameworks that we've started to use is RxJava, which was developed by the Netflix guys who have come together and put together a really good library. And we've started to use that to kind of replace a lot of the work that we do when retrieving information from, whether it be from the database or from our back-end APIs at the moment.
And so you wanted to show us a demo of one of the flows that you have refactored using this reactive programming paradigm. In your Android application.
That's correct, yeah.
So let's see the demo.
Sure. There's a number of areas where we've done that refactoring, but I'll show you one of the screens where we've done this. So for a user who basically wants to sign up, they come in. We've already got a Google account on here, so we'll sign in with Google. We accept that. That logs us in. And we'll see here what this is our onboarding process where we're able to actually see a number of different categories. For someone who's just signed up, they can basically find some of their favorite artists maybe. So if they like rock, they can go in here and they can see all the different artists that are
so
popular.
This data is something you pull from your server.
That's correct.
The list of genres and the list of the top artists in these genres. What we want to do here is on the device call a network API. So something that returns data from the SoundCloud APIs, and process those data, get them back on the main UI thread and display them. So if I wanted to do this by hand, because this is a very, very common problem, doing things asynchronously. If I wanted to do this by hand using threads and synchronizing the results, what would be the amount of work?
There is, if you really want to go to the very low level and kind of schedule your own threads and worry about synchronization, I mean, concurrency is a very difficult problem to solve when you're developing software. There are frameworks that are available or components that are available in the Android SDK, such as async tasks that handle this, but they are quite basic in what they provide. They do take care of the low-level threading concerns. But when it comes to error handling or applying transformations on the data set or even, I guess, scheduling at times as well, it provides either no or very little functionality with regards to that. So there's a lot of extra functionality and useful functionality built into RxJava that I guess makes it more attractive than using some of the built-in Android SDK components.
So let's see how it works.
Sure, absolutely.
Here we have first a little bit of pseudocode to understand what will be going on. This helped me personally understand because once we go to the Java code, there is a little bit of extra syntactic sugar to make this work in Java. But the basics are actually quite simple. Can you tell us what is going on?
Sure. So you could consider that using kind of the publish-subscribe pattern or the observable pattern, you have your data stream, which in the land of RxJava is your observable. You want to observe your data stream, basically. So the first thing that you need to kind of obviously do is have an observable data stream. And the person, or I guess the component which is interested in this data stream, needs to subscribe to it. And that's what we see in the first line there.
So that first line actually launches the asynchronous processing.
Yes.
You subscribe the observable to an observer, And basically what you do is that you register this do next function, which is a callback.
Yep.
On your observable.
That's correct. So basically the work itself, very simplistically, the observable there contains all the logic required to retrieve your data asynchronously. And as soon as you call subscribe and pass in that do next function, RxJava kind of takes care of the rest to launch your thread and then basically execute your observable, which is the red line that we see there with the call function.
And the call function is something that you define. So that's your function. You define what work you want to do.
That's correct.
And then at the end, you will call that do next function, which you have been passed.
That's correct. So once RxJava calls your observable to execute it, you will do your work and obtain your data. And then you will pass your data to the callback function, which is that do next function that we've provided there.
So let's see that with real Java code now.
Yes.
So this is how you define an
Observable. It's because of the wording, a lot of people kind of misuse those for one another. But basically in this first slide, what we're doing is we're actually, a very simplistic example is we want to make a network call to some backend API. And so what we do is we try and be as functional as we can be in Java, and we create this observable object. And we talked about that call function, and that is where you do your work.
So the client.make request, that is your work, your API call.
That's correct, yeah. So you're making your API request there and you get back a response. Now, the next lines are where kind of a lot of the magic happens in a way. So you can see that you passed in the observer, which is basically that callback function that we were talking about earlier. And once you have your data, you pass it to the observer by calling onNext. And you could do this multiple times if you have a collection of objects, for example. You can loop over those and then basically be calling onNext multiple times to provide that data until it's completed. And at the end, once you've streamed all your data, you have to call onComplete to signal to the caller that the stream has ended.
So let us see what an observer looks like.
Sure. What we're doing here is, now that we've created our observable, the interested party wants to basically subscribe to the data that's going to come back from that observable. And you can see there that once again we create kind of an anonymous inner class, which is that observer, to the subscribe function, and it has to implement those three methods there. The first one, which is I guess the most important one, is your onNext function, and that is what will receive the data, and whatever kind of processing you want to do as a result of that data, you should be doing in that function there. And once you've received, and as I mentioned, that can be called multiple times, executed multiple times, and once you've completed streaming your data, you need to call onCompleted, and that will basically signal to the observer that the stream has ended and that there's no more data to come. Now, as I mentioned earlier as well, there's built-in error handling into RxJava. So if an exception gets raised that you didn't catch during the work function while you retrieve like a network IO error or something, that exception will automatically be handled by RxJava and will be passed through to the on error handler or callback in your observer.
That's very handy.
It is very handy.
And so the last issue we have to address is that RxJava is a generic framework.
Yep.
But on Android, you want your results delivered on a specific thread, which is the UI thread.
That's correct.
So how do you do that?
So the observable has two methods that basically we saw in the previous slide. The first one was...
Let's go back to
it. The first one there was a subscribe on. What that means is that the actual work, that's where you specify a scheduler that you want the actual work function to be completed on. So in this instance, it was making the API call. But the really cool thing is that the observe on method there that you see on the observable specifies a separate scheduler where you can actually specify which thread the data will be delivered on. Now in Android land, whenever you want to update the user interface on the device, you need to be doing that work on the main thread, on the main UI thread.
And so there are a couple more lines of code to define a scheduler that will handle the data on the API, on the
UI thread.
UI thread.
That's correct. Now this is very simplistic. There's a scheduler class within RxJava that you need to subclass and it has two abstract schedule methods that you'll need to implement. This is a very simplistic implementation of one of them, but what we do here is basically we specify that there's basically a handler which runs runnables on the main looper, which is the main UI thread.
And so the main looper is the main Android UI.
That's correct.
That is a call to the Android API.
So this is all mainly Android code, yes. And this will exist in, like I said, the scheduler that you'll subclass. And what this does is it tells RxJava to execute that action, the action.call class, the action.call line that we see there in the run method, which will deliver those results that are passed through on next to the observer on the main UI thread.
When you were shopping around for a library like this, have you evaluated other possibilities? In
Android, one of the common I guess components is obviously the async task and some of the other components that live in the Android SDK. There are I guess some extra, if for those that are familiar with libraries like RoboJuice, which provides some dependency injection functionality as well. They extend some of the async task functionality there as well. We've found with RxJava, in comparison to using some of these standard libraries or components in the SDKs, is that it not only takes care of a lot of those low-level concerns, but it provides some extra functionality to take care of the error handling as well. But on top of that, a lot of the times you want to apply transformations on your data. There's a lot of built-in functionality within RxJava to apply transformations like filtering or actually transforming the data itself before being delivered to the caller. And on top of that, one really interesting piece of functionality is that you can actually combine data from multiple sources. So if you need to go, for example, to your database and you need to go to the API, and then you need to compose the data set into a single stream of data, RxJava actually has built-in functionality to be able to do that quite easily. So there's a lot of extra functionality and useful functionality built into RxJava.
I hope you will enjoy playing with reactive programming. And thank you very much, Mustafa.
Thank you for having me.
For being with us on Root Access Berlin.
Sure. Thank you.